Hi, I'm David from Electric Teaching, and I'm going to show you a more complicated derivative using both the product and chain rule. Product and chain rule. This one's pretty complicated because right off the bat, if you look at this equation, we've got some major thing going on. Then the outside function. The outside function is ln, or the natural logarithm. The inside function is two things multiplied, two things multiplied. If you look, we have an x function times a square root function. And then again, to look a little bit deeper, we even have a function inside the square root. So what I see right here, right off the bat, is I am going to take the derivative of the outside and then times the derivative of the inside, but the derivative of the inside has a product rule. And then when I do that product rule, I have to mind another chain rule moment when I do the derivative of the square root function with the x squared plus 1 on the inside. So this is a big problem. It's always good to think about what we're doing first. Again, we're going to be using product rule. Fg prime plus gf prime is the way it kind of comes off my lips pretty well. And then we're using the derivative of outside. I'm just using the more theorem version of this, derivative of outside times the derivative of inside. And we're doing this in a couple of places here. So let's just try to take this piece by piece. First, natural logarithm, the most outside part of the function. How do I know it's the most outside? If I was to use a calculator, the first button I'd hit would be the natural logarithm. That's almost always a clear clue on what the outside function, which will be the f function in this case. So derivative of natural logarithm is 1 over x, or 1 over the thing on the inside, the stuff on the inside. So the first thing I'm thinking of is this is the derivative is 1 over that big chunk of functions on the inside, x times x, the square root of x squared plus 1. Now, I'm going to look at the inside, which is going to require a chain rule, excuse me, a product rule. So I'm going to put a big, huge bracket here because I'm multiplying this times the two terms that come out of f g prime plus gf prime. So let's give it a try. The derivative of the inside here is x f, or x. Sometimes I like to put this a little bit higher so that I recognize it's in the numerator position. So keep that in mind. I think I'm going to try to do that. Just nest it a little higher so I remind myself it's in the numerator position. Sometimes those basic things will help in a complicated problem. So keep it as lined up as you can. Sorry, where was I? F times g prime. Here we go with the big chain rule inside the product rule. So this function on the inside there, just to rewrite it here, find a little room, the function on the inside could be rewritten. So I can use the power rule with the exponent of 1/2. So I'm using this idea for the inside function, or the g function in this little moment here. So the derivative is x times 1/2 parentheses the original function raised to the negative 1/2, which is instructions to go downstairs and square root. Keep that in mind. Okay, so this is the derivative of square root of x squared plus 1. We got 1/2. Yep. Oh, times the derivative of the inside, the most inside part. So this is the derivative of what I would consider little g in here, little g inside here. And this is little f if I was using the product rule. So you can see it gets pretty complicated. I'm not done yet, too. I've got plus the derivative of x, f prime. X is 1, so I don't have to write that. So 1 parentheses, but I'm not going to write that. I think you get it. Okay, I'll be clear. I like to be a little explicit sometimes. X squared plus 1, the function itself, g. The function itself, g. So let me just double check. F, g prime, g, f prime. Yeah, got it. I think I was pretty careful of everything along the way, too. All right, time to rewrite. Calculus is done. Now it's just pre-calculus and algebra work, basically. So let's clean this up a little bit. I'm going to focus on the inside. In fact, I'm going to just rewrite the outside part here because I don't think I'm ready to merge it yet. Keep it in mind. It will hopefully come together with the multiply the denominator along the way here. So what do we have here? We've got a 2 and a half. Those are going to get canceled. Let me mark that clearly. The 2 and the 1/2 are going to get canceled. The x and the x, let me go ahead and just kind of cross them off to know I've taken care of them. Makes it me realize I've already handled it. Makes x squared. So 2x times 1/2 x basically becomes x squared. This is an instruction to go downstairs. Negative means go to the denominator or opposite side of the fraction, as I like to teach the students. Negative is opposite, belongs in the opposite part of the fraction. 1/2 is square root, so we're going to write that. Square root of x squared plus 1. Okay, and over here, I don't think we have anything else going on. Uh-oh, I see an error. I hope you caught it. I forgot the little 1/2 up here. I forgot the little 1/2 exponent on my g function. I did not rewrite g carefully. So hopefully you caught that. You've been kind of trying to get my attention, as funny as that sounds on a video recording or a video lesson. But hopefully you caught that. I like it when my students catch my mistakes. That means they're not just believing that everything is true. They're trying to make sense of it. So hopefully that, again, you caught that. Pardon my mistake. All right, let's close off with the red color here, and we can then start to go a little bit deeper into this problem. A little bit deeper into this problem. Common denominators would really help here. Common denominators here. So I am going to multiply this one part by the square root of x squared plus 1, the denominator down here. What you multiply to the top, you multiply to the bottom, or where you multiply to the bottom, you multiply to the top. Probably hearing some fourth grade teacher in the back of your head there. So we got 1 over x square root, whoops, excuse me, square root x squared plus 1. Again, I'm just rewriting this. I'm not ready to merge it yet. It's always a good idea to just keep rewriting it. Got a common denominator now. I like to always rewrite my common denominator first. Square root x squared plus 1, and then just work the numerator out. We got an x squared from right here. Bring down the plus sign. These two multiply. We're going to get x squared plus 1. Radical of x squared plus 1 times radical pretty much just removes the radical. Okay, collecting like terms up here, it looks like we're going to have 2x squared, 2x squared. So let me move things down just a little bit here. So we're going to get 2x squared plus 1 over the radical x squared plus 1. And now I'm ready to bring in the multiplier from the outside. And we got x times x squared plus 1. I think that's pretty good so far. All right, when multiplying these three items, remember we can multiply the last two first and then just set it up multiplied to the first item. So hopefully that makes sense. Numerator 2x squared plus 1. Denominator is radical times radical with an x out front. So what happens there is the radical times radical just releases the inside. X squared plus 1, no radical now, to the first power if you want to look at it that way, times the x. I think we've got the right answer. I'm not double check, looking around. Let me just double check the beginning. I'm going to stick with it. I hope I did this right. My name's David from Electric Teaching, and I hope that I have helped. Oh, by the way, you can always use the least exponent trick here. Again, I'm going to try to make a video for that. It's almost harder to do it that way than it is to do a common denominator, but it is a slick, fast move that you may want to consider as you get confident with these. Again, I'm David from Electric Teaching, and I hope that